Hey everyone. Oh, dude, this stupid Discord thing. Dismiss. Thunder. It's going good. How about you? Thank you so much for the prime. Holy crap, dude. I appreciate it. And Stooky, hey, congrats on the first. I saw that you snuck a little stream in this morning, but I was like still in bed and not fully with it, so I wasn't following what was happening, but I hope it went well. I actually am running away like right now, but oh yeah, no worries. We're just nabbing the first and getting out of here. Thank you, thank you. Okay. So last stream I was most recently struggling with number 8 here. I'm gonna mark it wrong because off stream I ended up looking at the answer and I actually got it like mostly right. Or I mean, kind of right. I gave myself maybe like I got maybe halfway there, but so just this one was just very weird. Yeah. So actually, yeah, I remember seeing you around when I've been doing this the last like week or two, but I'm trying to speedrun relearning mechanics. And so I was just working on that problem that's on the screen. I'm about to grab a new one. So I've been using this book here. It's very problem-solving focused. Their problems are pretty freaking challenging. But I'm just in chapter 3 right now, which is just 2D or yeah, I guess 2D kinematics. I've gone through all the multiple choice ones, and there's these word problems. Hey Divya. All right, 3.9. Car in the mud. Use the A-level topics just if you're missing any fundamentals. That might not be a half bad idea. I don't know. This book has been pretty good so far, though. Kind of like it. Yeah, so anytime Angular stuff gets involved, things get really weird. Let's figure out what this one is saying. Oh my gosh, my mic didn't pick that up. Wheels stuck in the mud, spinning in place. The radiuses are and the points on the rim are moving with speed v. I'm doing good too. Thanks for asking. Bits of mud depart from the wheel at various random locations. In particular, some bits become unstuck from the rim in the upper left quadrant as shown in figure 3.11. This is very specific. What should theta be so that the mud reaches the maximum possible height above the ground as it flies through the air? What is this maximum height? You may assume v squared is greater than gr. Oh my god. For maximum height. Hey Jaden, yeah, I remember you. It was literally like 2 days ago that I saw you last. So, you know. Blackbeard, hey, well, welcome in. I know a very tiny bit of analysis. It's definitely not my specialty though. Like, if it's like something you'd seen like a first semester analysis class, I might be able to like get my head around it. Hey Rex. But there's a lot of people around in chat who are enthusiastic about analysis. So if you want to like talk about it, then like even if I can't help you, someone around should be able to help you. And since you are new to the community, I like to let people know that I'm not the only math streamer on Twitch. There's a whole list of them here. And I'll say, if you're interested in analysis in particular, e to the 2i pi in that list is very enthusiastic about it. But I think like Penn Center and Instaplex Pachinko are also like pretty good with it out of that list. Algebra 2 honor sucks. Oh yeah. 7 watch streak. Thank you, Rex. Holy crap. Yeah, welcome in, Blackbeard. Glad to have you. Been reading Spivak's differential geometry. There's some weirdly analytical theorems I could use clarification on. Yeah, I never done differential geometry. It'd probably be on me personally. I feel like I've heard Ian Stuke at least making references to differential geometry. I don't know how much they've gone into it though. If you only can try to post it, but there's a good chance that I wouldn't be able to help with that one. Yeah, Jaden, go ahead. You're looking for the height of the piece of mud in terms of theta, and we differentiate it. I think so. It's just that the weird thing with a problem like this is that for various like values of theta, so like I imagine we get the most y velocity like right here when theta equals 0. That's when we have the most y velocity, but that's not the only piece of the puzzle where we get more of a head start, like more initial y position the higher up we go, if we're at like, pi over 4 or something. Oh, Muhammad Squared, welcome in. Thanks so much for hanging out. Right now I'm just doing some physics studying until we get a question from chat. It's unless someone over in the YouTube chat is going to post one in a minute. And also for anyone who's new around here, I dual stream to Twitch and YouTube. So if you're talking to someone who's not there in the chat that you're looking at, then that's why. But yeah, I do like your idea, Thunder, of trying to find a function for what's going to happen here and taking the derivative of it. But figuring out what the function should be is a little bit difficult. That's also the point of the problem. So let me do the Rubik's Cube that Mean Machine Rex just redeemed, and then I see Jaden just posted their question. All right, scramble it. Down comes like that, I think. It doesn't really matter because it all scrambles. Okay. Inspection. Okay. My fingers are cold, so this is already going to be a bad solve, but, no excuses. Oh my god. Oh, dude, there's nothing worse than trying to help a Rubik's Cube with cold fingers. Oh wow, that was really, wow. I got really lucky there. That should have been a lot worse time, but I got to skip the last step. The world record, it's something crazy like 3 or 4 seconds, I think. Yeah. Thanks for the redeem there, Rex. All right, so Jaden is saying ugh. There we go. Okay. This is Jaden's problem. Function f of x equals x cubed minus 6x squared minus x plus 30 can be used to describe the relative stability of a small boat carrying x passengers, where f of x equals 0 indicates the boat is extremely unstable. Really? That's a weird function to represent such a thing, but okay. Is it saying that the boat will be infinitely stable with infinitely many people on it? With 3 passengers, the boat tends to capsize. Okay. This is kind of a stupid word problem. I'm going to be honest. But basically what they're saying with just removing the stupid boat situation from the problem, where they're saying they're giving you a cubic equation here, and they're giving you that f of 3 for 3 passengers is equal to 0. 3.13 is the best single. Wow. And so they're asking you to... She got 5 passengers? Okay. Basically, they're giving you one root of this cubic here, and they ask you to find the other 2 roots. So, like, we could write this cubic as x minus 3 times, like, something involving x squared. And I'll just put, like, question marks here. And we can figure out what that thing is by using division. So Jaden, do you know polynomial division, like long division or synthetic division? Yeah? Okay, so I'm not sure if you know both? Okay. We're learning both this chapter. Okay, so both of them will work here. I'll show the setups for both. So for long division, you would set this up. And for synthetic division, you would set this up. I mean, synthetic division gets arranged a little bit differently sometimes. That's the way that I was taught. And so, I don't know, we can do, unless you want to see one in particular, Jaden, we'll just do the synthetic division. Would the answer be the remainder of that? No. So if we get a remainder here, that's actually, we do not expect it to get a remainder here. If you do, something probably went wrong. If you divide out a 0 from something, you shouldn't get any remainder. So we laid the boat on concrete. Average the best 3 times of 5 attempts in major. Yeah, I've actually competed in cubing competitions when I was in high school. I'd only just started to solve Rubik's cubes, though. My friends are more into them than I was, so I didn't do particularly well, but it was some good fun. So just going through this synthetic division, I probably should have explained what I was doing here, but you take the first number, you just drop it down as is. Now you take this number, multiply it by 3, and put it here, and then you add down the line. So -6 plus 3 is -3. Now you take that -3, multiply it by that 3, and you get -9. Add down the line, -10. Now we're going to do -10 times 3 is -30, and up to 0. Perfect. So there's no remainder here. And so I'm going to get rid of these question marks. And remember, this line here are the coefficients of whatever polynomial we get back out. Well, everything but the last one are the coefficients. The last one is the remainder, as you were saying. But we're going to get x squared minus 3x minus 10. And now this is a quadratic that we can factor in many different ways. I like the it's something called the AC method, I think. Hey, cool deep. And I can see this one's going to factor to x minus 5 times x plus 2. Because negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. Can I solve Sudoku? Well, I only know the basic method of solving Sudoku. I don't know how to do anything crazy. As much logging, my understanding how that worked. Oh, yeah. No, I don't remember how the competitions that I did worked. I think it was the same format, but it's been too long for me. So if we take this thing and set it equal to 0, which is what the world problem is asking us to do, we find that x equals 3, 5, and negative 2. But this is where the word problem does matter, because they're asking what other passenger loads could cause the boat to capsize. So accurately, we found 3, which is the one that they gave us, so that's good. We get 5 as another possible passenger load. And then negative 2, it does give you 0 in the cubic, but it doesn't make sense to have negative 2 people on a ship. So we would throw that one out. And since 3 is the one they gave us and they're asking what other passenger loads, I would say just x equals 5 is going to be our final answer. Does that make sense, Jaden? What is the integration of dx over a squared cosine x plus b squared sine squared x? I think that's a pretty crazy problem, Coldeep. No worries, Jaden. Question was clearly created by an education major. Let me look into that, Coldeep, because it might not be as hard as I'm thinking, but I feel like maybe it's not that. It looks familiar. Let me. Oh, does it involve complex numbers? No, this is something. What the heck is happening in that person's answer? Yeah, I mean, I think these integrals or like this integral that we end up with might be a little bit too tedious, but I might Wolfram Alpha this. Um, oh yeah, I've been recommended his like cracking the cryptic YouTube videos. I haven't actually watched them though. Hey, Frozen. Raj is asking, find the distance to the point 3, 5 from 2x plus 3y minus 14 equals 0 measured parallel to the line. Oh, I haven't seen a problem like that before. Um, I think I see what to do though. Let me all right, so Coldy, if you are still here, I'm going to do Raj's problem first. 'Cause I think it's going to be a little bit faster. I'll try and get back to this and at least show the idea of it, but this is going to take a while to do. So Raj is a bit quicker, and I'd like to do that one first. Uh, the the integral is one that's written right, like right there. Okay, so I'll link the stack exchange thread. It's not, it's a little bit annoying, but there's a clean enough way to do it. Also, I haven't seen Cooldeep type anything, so I feel like they just put the question and left. So the first thing I want to do is look at the line that I want to figure out the slope of this line. X minus 2y equals 1. So let's isolate y. 2y minus 2y is equal to 1 minus x. Now we divide negative 2 by everything. So we get 1/2 x minus 1/2, right? Virus stress sub might work. So basically, this is 0.35. There's probably a vector way of doing this too, but I'm gonna not try to do that because I for one, I don't know how to do it exactly, and for two, I don't know if you know vectors. So I can see we have a slope of 1/2. So any line with a slope of 1/2 will be parallel to the line that we're given. And so we have a point and we have a slope. We can figure out the equation of the line that we actually want here. So what we can do is if y equals mx plus b, we want a line y equals 1/2 x plus b, and we just need to figure out what b is. And so we're given a point 3,5, so let's plug that in for x and y. So we get 5 minus 3 over 2 is 7 over 2 equals b. So then y equals 1/2 x plus 7 over 2. Okay. So we now have the equation of the line that goes through the point that we actually want. Now we want to figure out where it intersects the line that we're given. So what would I do here? I think we already have, I think I'll take this value for y and plug it in up here. So I'm going to take 2x plus 3y minus 14 equals 0, plug that y in for that y, and that'll give us where these things intersect. So let's distribute that 3. So group like terms, 2x plus 3 over 2x is 7 over 2x. Uh, 21 over 2 minus 14 is minus 7 over 2. Wow, that's kind of funny. So we're going to get 7 over 2x is equal to 7 over 2. And so x just equals 1. And so so now x equals 1, let's figure out the y coordinate of this thing. So I'm just going to plug it back into this one. It doesn't matter where, but if x equals 1, then y equals 1/2 times 1 plus 7 over 2. So we just get 8 over 2, which is 4. So now the problem has become... all of this was in the name of figuring out what the point that these two lines intersect is, and now we just need to find the distance between 3, 5 and the point we just found, 1, 4. And so there's a distance formula that we can use here. So the square root of x1 minus x2 squared plus y1 minus y2 squared. So that's 2 squared is 4, plus 1 squared is 1. So root 5. And that's just our answer there, is root 5. Oh, you know what? I just remembered, Rex. I know that Fembox loves Sudokus. So, Raja, I hope that helps. And if you have any questions on what I did there. And Kuldeep, I haven't seen you type anything since you put that integral in chat. It's kind of a long one, and if you're not here anyway, I'm probably going to move on. Because I feel like I understand the idea of it from that Stack Exchange thread, so I don't really want to look through it for myself. No worries, Raj. Okay. All right, so I'm going to go back to looking at this mechanics problem here in the meantime. Yeah, Sereno. I kind of... that's part of why I don't feel the need to reinvent the wheel there. Sorry, I've just been arranging to go play pool with my friends, or billiards if you're not in America. And my friends are joking about like trying to like hustle people and have me figure out all the geometry. Although I'm terrible at pool, so joke's on them. No, they're different games? Pool and billiards? I didn't know. It's news to me. The poker night fell apart, Jed, unfortunately. It never happened. It's pretty common for that to happen with my friend group. So that'll probably happen one day, but the 15 ball and 9 baller pool. Wait, billiards has no pockets? Huh. Snooker. I've heard of snooker. I don't know what it actually is, though. Eldritch? I mean, you don't have to use either, but, like, just, yeah, you can use bits if you want. I hate when people think math is to make money. Yeah, there isn't a whole lot of money in math. I feel like there's a weird thing where some people feel like you're gonna make a ton of money, and some people know that you're not gonna make any money. That's probably maybe reflective of the reality though, that a lot of people don't make money, but some people do. Yeah, I guess it depends on like what you're doing with math, like Obi says. Neuronets is getting big. Oh, Eldridge, if you're talking about the Discord thing, I don't know. For like that Discord drop, I don't have the pop-up open anymore, so I'm not sure. If anyone knows if you can use bits to do the Discord like drop thing that's happening, let us know. But it's like 8-ball pool, but 1-ball pool. Okay, Rex. Yeah, I feel like maybe I've heard something about like it's about like just being able to hit the other balls or something. I'm not sure, to be honest. A friend of a friend made a metric shit ton of money by making a microsecond trading account for a hedge fund. They gave her $1 million bonus. She quit in 2 weeks because she has a soul. Wow. Don't blame someone for making some money there. Algorithm. Oh yeah, I read account, but I figured that was like an algorithm. Henry Sullivan over on YouTube asks, find the flux of the vector field F. Your A push homework, you or read Lee. What is Lee? I do agree that A push is pretty you. I wasn't a huge fan of my A push class. They made us memorize a chart with every single president, their years, and something notable that they did. Oh, it might only be subs then. Intro to smooth manifolds. Oh, neat. I mean, you probably should make sure you get your A push homework done at some point. It sounds like the lead thing is just for fun, but I guess it's up to you, Blackbeard. Find the flux of the vector field F outwards through any circle centered at 1, 0. Is R just a constant here, or what is R? Oh, it's just the distance from origin. Okay. So my multivariable calculus is a little rough here. I've been getting a little bit better because I've been doing some physics, but I feel like flux, like what does flux mean in 2 dimensions? It doesn't really make sense to me. Let's see if I can just find an example from Paul's notes. Oh, does Paul even do flux? Paul might not do flux. No, okay, no, here's flux. Okay, so it still works like that, where it's just like the amount crossing the barrier perpendicular to the curve. Okay. Because I feel like it's a pretty decent chance of getting 0 here. Oh, no, no, not necessarily. Maybe that's the a less than 1, a greater than 1 thing. Maybe if a is less than 1, I feel like you would get 0. Yeah, okay, so Henry's saying 0 for a is less than 1. Makes sense. How do we, like... I'm a little, like, weirded out by how we should calculate this. So it sounds like you maybe already understand the a less than 1 case. If a is greater than 1, what does this field kind of vaguely look like? Like everything on y equals x is just going to look like that. These are all unit vectors. If we're just below y equals x, then x is more than y, so they should be a little bit flatter. And eventually, like, leveling off to be nearly horizontal. Oh yeah, so they should be splitting off. Okay, I think I can imagine what this field looks like now. And so we're centered at 1, 0, and the radius is more than 1. Um, and so I guess the idea for getting non-zero flux in this case is that, well, oh no, no. Does being off center really affect it? If these all are unit vectors, because if we get rid of these r's, it looks like that, right? Oh wait, it's r squared. Also, they're decreasing. Okay, so these are not unit vectors. They're getting shorter the farther away from the origin we are, right? And that's why we wouldn't get 0. Okay. Because, like, this side of the circle is getting shorter vectors than this side. Okay, good to know. Um, and so I guess we need a little vector, like, ds here that's normal to the circle. How could we define that? Yeah, right. The flux should always be positive. That's a good thing to note. Hey Arthur, everyday what? So can we parameterize a circle by like, or like this like, see, okay, start by parameterizing a circle with x equals 1 plus a cosine t and y equals a sine t. You honestly didn't know where to go from there. No worries if it's a bit complicated. Hey, Fembucks. Yeah, so that's where I was just trying to like go towards myself. Um, so 1 plus a cosine t and a sine t seems like a reasonable parameterization to me. Um, but this is like just as sweet. We want like the unit vector version of this. Right? So do I do DEs? Relatively simple ones, Hudson, yeah. If it's like an ordinary differential equation. Oh, Eldritch. Thank you so much for the sub, Eldritch. I hope that that Discord thing works for you. Free Nitro for $1? That's not bad, yeah. Yeah, Henry, like this question shouldn't be that hard. I'm just very rusty with getting this stuff. Unit vector pointing out a circle always be cosine t sine t. Yeah, but I guess when we put the a in front of it, that scales it. Um, uh, like I know I can do this. I'm just uh yeah, it's and that looks like a first order linear DE. I do know how to solve that. I'm working on Henry's question first, but you can be right after that one. Why are we? Hmm. And sorry, I'm saying multivariable calculus. I know this is only like two-dimensional, but Flux you usually don't encounter until multivariable calculus. But I'm DS normal component of f along C. Okay, so this is a very similar problem. It's the same vector field, but the circle is centered at the origin. What do they do here? Oh, well, if it's centered at the origin, that's actually way simpler. Formula using flux of f across C. M dy dt minus n dx dt. Well, we could do that. Because we know m and n are from the original vector field f, right? Straight from my notes. Okay. Yeah, I'm sorry I can't explain like intuitively why we would do this, but we can try to follow this formula and see what it spits out. So one clear revolution of the circle will be from 0 to 2 pi in terms of t. Oh, we do need to we need to get f in terms of t, right? Before we can do this integral. Looks like it. Okay. Yeah. So x is equal to 1 plus a cosine t, and y is equal to a sine t. Oh wait, no, yeah. So we also know that f is 1 plus a cosine t over, well, it's a circle of radius a, so can we just simply say it's a squared for r squared? Does that make sense? It might be 1 plus a squared. R is distance from the origin, not... Oh, really? Yeah, okay, yeah. I see that, yeah. So we can just do the old-fashioned way. X squared plus y squared, 1 plus a cosine t squared plus a squared sine squared t is equal to 1 plus 2a cosine t plus a squared cosine squared t plus a squared sine squared t. We can use the Pythagorean identity there. All right, I guess that's what x squared plus y squared is. I don't think we can clean it up anymore, unfortunately. Well, that's going to be annoying to integrate. I guess let's see what it turns into. It might clean up. Oh, not 1 on this one. You end up doing partial diff. Hey, Phobos. I don't see what you mean there, Sereno. Okay, so 0 to 2 pi. So we had the formula that was, I was saying, m dy dt. Yeah, so I'm curious to see what this integral looks like. It looks a little not nice, not gonna lie. dy dt is a cosine t. Plus n, which is a sine t over 1 plus 2a cosine t plus a squared. And then dx is minus a sine t dt. Okay, is this the worst thing in the world? Possibly. I'm not saying it's not. Or, yeah. Well, it's just... I still have hope that it'll clean up. I do see we'll get a Pythagorean identity. So we get a cosine t plus a squared cosine squared t plus a squared... Oh, minus. No, it's not Pythagorean identity because it's minus. Wait, there's a minus in the formula. Is there? There's a minus in the formula. Sorry. That's a minus, not a plus. So we do get a Pythagorean identity. Yeah, thank you, Henry, for noticing that too. Okay. So we can factor an a out of the integral. And we're going to get a cosine t plus 1. Or 1 plus 2a cosine t plus a squared dt. Well, that's annoying, isn't it? So it's because of the, I factored an a out of the top. Oh, wait, I messed up an a. It should be cosine t plus a. But there's still an a out front here. Yeah, this integral is not nice. I'm looking. I don't see a trick. Let's see if Wolfram Alpha finds a trick that I don't see. Hey, the goat. Can you go through why one observes the wave function norm squared in reciprocal space when going further from a 1D slit, but close to the slit you observe the Fourier transform of the wave function? I cannot go through that because I don't know how that works. I'm sorry. Okay, well, that's not good. Wolfram Alpha can't do it either. Is it a Green's theorem thing? Kowalski, analysis. Um, I just remember how you use Green's theorem. Like it's been a minute. Um, 0 to 2x. Explain this. I understand it's a little bit hard to explain. So we're only working in two dimensions, so we don't have a sphere. But I don't fully understand what I'm doing right now, so I'm having a hard time explaining it, to be honest. Uh, yeah. Um, but like, I guess I'm trying to figure out what dx and dy are, and or like what, like, I guess the line integral that we would have. We can keep it for now. Who cares? No, actually, I want the space. I'm getting rid of that. It's a dead end. The line integral that we would have is x over x squared plus y squared dx plus y over x squared plus y squared dy, to try and put it in the format that's in here. And then we need to no, Eldridge, yeah, I absolutely don't know. And then we need be better to prove it. You're welcome to try to prove it. I don't know how. We figure out the balance. So we take the partial of that for x and the partial of that for y. Partial of this with respect to x minus y over x squared plus y squared squared times 2x minus partial of that with respect to y will be nearly the same thing. Okay. And then we need to figure out the how to represent this circle. I think its field isn't defined at origin. So Green's theorem breaks. Oh, that would be an issue. Dang it. Yeah, Henry, you're right. They don't have continuous partial derivatives on the region. It's a good question. I feel like I should know how to do stuff like this, but I evidently don't. um, something else that we can try here. Yeah, Fenbox. That's why I'm really annoyed that I'm struggling with this. I'm trying to figure out how the book would do this problem. Because I know there'd be some clever way. And Fizzbuzz, we're just figuring that it's zero flux for a less than one. Because anything that comes in should go right back out. Oh wait, is that even true though? It's getting weaker. A less than zero, A this one goes to zero, greens work fine. Okay. So yeah, at least Henry over in the YouTube chat is asking the question. It seems like A less than one is a lot easier and it's just zero. Good morning and good evening to you, Lucas. I hope you have both. We don't need to choose one here. Um, yeah, I hope your afternoon sucks though, Lucas. If you have a good afternoon, I don't want to hear it. No, I mean, this type of stuff you do a lot in physics too, but this is separated from any physical situation. It's just a math question. Um, I'm sorry, Henry. I think I'm stuck on this. I'm really annoyed. I think I should know how to do this, but I can't really figure it out right now. Um, yeah, Lucas, I can look at your question. There's someone in the YouTube chat who asked one before, and I've kept them waiting. Hudson, are you still here about your differential equation? Okay, yeah. Thanks for your patience, Hudson. Um, yeah, I dual stream to YouTube. So yeah, Henry, I'm gonna keep on thinking about this. Like, I do have a Discord too. Like, if you try posting there, so someone might be able to figure out and get back to you. Or if I do, I'll like write to you. But annoyingly, I just can't figure it out right now. Don't know a minute of supply mass. So you have 1 plus e to the x plus y. 1 plus e to the x plus y plus xy prime equals 0. Okay. So this looks like a first order linear differential equation to me. And there's a form that I'm used to writing these in, which is, I'll write in 2 steps here. X prime plus, or xy prime plus y equals -1 minus e to the x. And normally we get this y prime to be alone here. So I'm going to divide out the x. Y prime plus 1 over xy. Oh, is this going to be pretty? Actually, yeah, it might be. Oh my, I forgot I had that alert. That's a little loud. Oh my god, that's a jump scare. Core, thank you for the follow. I need to turn that one down a little bit, I think. Oh. Ben, that's a pretty good trick there. Okay, so that's a neat trick, Ben, but I want to show this person the general way of doing it that should always work. I do like that a lot, though. Yeah, 998. Sereno, yeah, but there's a little bit of a line right now. I'm working on this differential equation, and then Lucas is gonna have a question. I think, what are integrals again? Is it those f prime? The integral is like the opposite of f prime. It's going the other direction. I can talk about it more after this. Okay. Linear. I want to show you Paul's online notes here because I like this site. The differential equations part is a little bit shakier than the rest of it, but it's still pretty good. So what I did is I just wrote into the format they have here. So y prime, some function times y equals another function. Oh, awesome, Ben. Yeah, I think it's a really fun thing to do a tutoring stream like this, although I kind of get, it's mostly me getting schooled by people in chat, so just gotta learn to embrace it. It's basically a differential equation in this form has a way that it can always be done with an integrating factor. And we call it mu of t, and mu of t just has a formula. Mu is the e to the integral, e to the integral of p of t. And p is the function in front of y. Okay. Let's figure out what integrating factor is. It's e to the integral of 1 over x dx, which is e to the integral ln x, which is just x. We're in Discord. Do I post the question? I guess in math discussion, Sereno. And so now we have a formula for y, which is technically it's going to be plus c, I think. No. Wait. Let's not worry about that right now. It's gonna be the, oh yeah, we do it here. It's gonna be the integrating factor times the integral of the integrating factor times whatever function is here. plus c. The plus c in the parentheses here is important because it is going to get the integrating factor slapped onto it. And I think this setup is good. I'm just looking at Paul's notes right now. Yeah. And so there is a way that you can like figure this out and not have to memorize it, but honestly, I just memorize it. So let's figure out what this integral is. The x's and the x's inside the integral will cancel, so you just get integral of -1 minus e to the x dx plus c. And technically it's like too early to put the plus c here, but it's good to remember it, so I write it early. Oh yeah, and OB has covered this in his differential equations class. Okay, so this thing in here integrates to -x minus e to the x plus c. And now we just multiply the x inside everything. So -x squared minus x e to the x plus c times x. And that's just the answer to your question, Hudson, right there. Sometimes they give you an initial condition where that lets you figure out what C is, but if they don't give you one, then you're kind of done there. Speaking of the basic steps, I have one more question if you want to help and check it into the list. Yeah, so let me address Lucas's question and then Sereno's, and then if I can come back around to you. So Lucas asked, what are integrals again? Is it those f prime? So Lucas, an integral is it's the opposite. So f prime is the derivative of f. And then this fancy s, and usually you integrate with respect to a variable, is the integral of f. And these are opposites. So if you do the integral of f prime dx, you haven't really done anything. You just get f right back out. English is hard with math, yeah. Okay, yeah, plus c. Thank you, syntax. But the plus c isn't the important part here. And so kind of as it's pronounced as voiceless in old scripts, like I don't know how you pronounce something voicelessly. But kind of the explanation of what these actually mean are just take any generic function. I'm just drawing a random curve here. F prime is the slope of the tangent line at any point. So if you want the tangent line like right here, then f prime will give you the slope of that line. The integral of f will give you the area under the curve from one end of x to the other. So if I want to integrate from this x to that x, we're adding up that area plus that area plus that area. And integrals are weird because you could have a negative area if you're under, like those two areas underneath the x-axis are negative, but it's kind of just what you get. With an F sound? Oh yeah, it does like the old fashioned F. You're right. Is he mad about you saying X? Please stop. I don't have a girlfriend. Are you saying that I used to date your hypothetical girlfriend? I don't know if I get it. Oh wait, was the actual question the thing you just put in the forum? Oop. Oh, I thought your question was about the F prime thing. Okay. Uh, Sereno, are you Veritas? How many numbers of the form A, B, 7, C, D, E? I don't think I know how to do that question. I'm sorry. Uh, all right. So you want to do 28D, Lucas. Um, Let me drag this in. Now to meet some friends for dinner. All right, Finlux, enjoy. Reaper, hey. Hope you're doing good, man. Hope your dinner goes well, Finlux. Yeah, I mean, we'll see. The followers have been just like trickling in, but only two more to go. I'm sorry, Sereno. It's I don't know how to even start it. Um, John, how does domain and range work for multiple variables? Like 1 over square root 4x minus y squared. The domain works pretty much the same. You just try to look where like the denominator equals 0. So you get relationships between x and y. It's the same idea though. I can talk about it more later. I have to get through this question, and then there's a follow-up question. I'm gonna start writing down the queue again. Lucas, with the question I'm about to do. Hudson, that had a differential equation. That I'm going to copy down right now before I forget it. Dx dt plus x equals root 1 minus t squared x of 1 equals 0. And then we'll get to u, John, if you don't mind. Four minus x squared minus y squared. And 3D, I don't think I can do that question. I'm sorry. There's a lot of GCDs and LCMs happening there. Mateo, I stream Tuesday, Thursday, and Saturday. Yeah, I had a crazy like 8% queue or 9 or more on Tuesday. I would like to make a bot that'll keep a queue plus do a few other things. But until then, I'm just writing it down. So something about determine if the function is invertible. Is that what they want us to do here? Yeah, I think it's Dutch, Rex. You know what? Google Translate can do images. That might be a helpful thing here, because you might not know what the words in English are. Or I assume you don't know what the words in English are. Lucas, let me save an image. Ugh. Where is it? Downloads. I have it already set to Dutch from whatever I was doing last time, I guess. Investigate graphically whether the function is invertible. Okay, if the function is not invertible, I don't have possible restriction of the domain such as function restricted. Okay, nice. That's perfect. We can do that. So are you allowed to use a graphing calculator here? Like if I just plug this thing into Desmos, is that allowed, or do you have to graph it by hand? You can use your graphing calculator? Okay, cool. Let's use that to our advantage then. 4 minus 3x minus x squared. 4 minus 3x minus x squared. Okay. And then the important bit, yeah, that is a weird function. It looks like a circle. I guess that makes sense. Oh, yeah, okay. Always graph by hand? If we're allowed to use a calculator, I think it's you should just use a calculator. I know you're joking, but I don't know. If a calculator is allowed, I'd much rather use a calculator than make a mistake. So yeah, if we try to invert this, we're gonna get can I easily tell what this circle is? Quick time event to math streamer. The circle is centered at, I think, like 3 plus 2.9, 32.9. Actually, I don't think that's supposed to even graph. Okay, you know what? I prefer the graph by hand right now than trying to figure out what the actual function would be. I mean, I think the center. I think the radius is 1.5 as well, but it was like being weird. I didn't want to I didn't want to like bother like figuring out the actual what the inverse would be after that. I was trying to go for the intuitive explanation that if we reflect this thing across the line y equals x, that's not x at all. We're gonna get another semicircle that's gonna look something like that. Some of you'll try to make a circle but failed. Yeah. Oh, Ben got it? Okay, nice. And so this thing, it's not cleanly invertible because this thing fails the vertical line test. It's not going to be a function. And so the first part of the question was just to say yes or no to that part, right? So graphically, I'd say the function is not invertible. But we could restrict the domain and get something that is perfectly invertible. We have a different way to calculate it? Well, let me know, I guess. Put the function in the graphing calculator to see if there are 2 y coordinates. Oh, yeah, that works too. So yeah, we could absolutely do a horizontal line test here. Excuse me, Desmos. A? Give me a slider for A. A is not equal to X. B? 2. Okay. Basically, for any horizontal line that you can draw, does it intersect 2 points? That's the exact same thing. So that's actually maybe like a quicker way of thinking about it. So that's completely valid. Yeah, Ben, I just realized we're gonna find the center of this thing anyway. So yeah, I'd say like just for me that like horizontal line test, you can tell this thing will be invertible. That's completely fine too. And so the issue that comes up here is if we want to restrict the domain to make it work, at least sort of, we want to kind of cut this circle in half. And that's going to be our, like, we want to cut it in half at the center. What I tried is by finding the domain, is by finding the function of f prime. Like doing a derivative? I wouldn't use the derivative to find the domain here. I don't think that applies. Or I don't think that helps you as far as I can think. Um, if the derivative helps you find the domain, I don't see how. Sonia, do you know how to see if a function has a vertical cusp or a tangent? Oh, what is a vertical cusp? Is that when a function... Oh, it's probably when a function does that, right? When... Oh, shoot. That's when the... It's when the first derivative goes to infinity, I think. Like if it has an asymptote, you have to check that. Like, so like if the denominator of the derivative has an x in it, you should check x equals 0. Or like maybe x squared is a better example. I think that's generally how you tell. How does 2 plus 2 equals 4? Mrs. Smith doesn't tell me. Well, if you have 2 fingers and you add 2 more fingers to it, you get 4 fingers. Hope that helps Daniel. So yeah, Sonia, I equals W, yeah. Actually, that's triple U. It's not even W. So your fingers show? 2 plus 2. Are you doing that? Oh, yeah, see it, Ben. Thanks so much for hanging out. For example, C, my answer is also no, and your answer is x is less than 4. Just touch the tips? Like that? Or no, like that. Okay. I mean, that's not... I don't know. I guess so, but if you're doing that, you may as well like, oh, why not make a hashtag or a pound? Isn't 4 over x plus 4 invertible though? Let's split up and search for clues, gang. 4 over x plus 4. I see this function is invertible. Isn't it? Is it no, it's probably not self-inverse if it's translated. 9 plus 10 equals 21. Oh, that's because Vine told me that. W is Greek for omega, which is the end. The end of the world is 2 plus 2. Take that, Mayans. Was I looking at B? Oh, it goes... Oh my god. You're right. It goes A, B, C, D. I wasn't expecting that pattern. 1 over x squared plus 4. That, right, is not invertible. Without a restriction. Well, I think the real issue here is that x should be greater than or equal to 0 or less than or equal to 0. Who said we're struggling, Daniel? Because this function is even. So I don't think 4 matters here. But like you can see, it's just like it's split in half right at x equals 0. If your GF ever asks you Desmos or me, what is your choice? Desmos all the way. You know, if she makes you choose, she's not worth it. Peacemaker, I wasn't able to figure out the flux question. So Lucas, how I'm figuring this out is so the issue with saying x is less than or equal to 4. So like I'm literally just like picturing this in my head. If we have y equals 1 over x squared plus 4 drawn terribly. You have to draw it terribly or else it won't work. No. So you were saying, actually, oh, well, no. X is less than or equal to 4 would not work. So you're essentially taking like this part of the graph here and reflecting it across y equals x. And it's going to end up looking something like that, where it's just like suddenly cut off there. And so it's this extra little bit that's causing us issues if we do the vertical line test here. And so I guess you could also see that with your way, if or with like the horizontal line test, if you just draw a horizontal line and try to intersect it twice before you've hit your cutoff point. Like I can draw this horizontal line here before x equals 4 and I still hit it twice. And so that's the issue. Now, if you want to say x is greater than 4, I think that would be fine if you took this part of the graph over here. But that's how I think about these. I think about it very like visually like that. What if she's more powerful? Then you better start running, I guess. I don't know. Oh, Sereno, maybe that's the idea of what Lucas was supposed to do with the derivative. I see. If monotone increasing and injective has inverse. Yeah, so there is a calculus way. Okay, so I see how that helps now. Thank you for saying that. For f prime, y equals root 4 minus x. We're allowed to graph and calculator here, but I kind of want to explain it more intuitively. So Lucas, I think the reason that f prime is helpful here is because anytime the derivative is 0, we have a peak or a valley. And those peaks and valleys kind of mean that you're almost certainly going to break this horizontal line test because you're coming up on one and coming down on the other. So that's why the derivative can help us figure out whether things are invertible or not. So if we're given the function f of x equals, what the hell am I writing? Equals 1 over x squared plus 4, we can find f prime x is 1 minus 1 over x squared plus 4 squared chain rule times 2x. So rearrange it a little bit. X squared plus 4 squared. So maybe I should explain the derivative a little bit more because it seemed like the thing you got for f prime is a little bit different. Brian Douglas, how to prove the Riemann hypothesis? It's a secret, and I'm not telling. Oh, wait. I think... So wait, there's the... Oh gosh, Lucas, I don't remember... So I think... Do you know what a derivative is? Or like, are you in a calculus class? Because I think your f prime might be different from what I'm thinking f prime is. Jaden, there's another queue going now. I can add you onto it. I'm still on number 1 with Lucas. Okay, so let me throw out what I just said. I think I know what you're doing, and maybe it's not. Here, one second. My mom just texted me. Um. Oh, what the heck? My mom was finding like I'm very into coffee. My mom just found two coffee places that I haven't even heard of. That's awesome. Okay. Okay. Anyway, I'll reply to her in a second. So, Ken Yash, I have a bachelor's in applied math. I cover things that you would normally see in like a first year undergraduate like degree and lower. So like calculus, a bit, calculus differential equations, anything like below that. I show slowness. That's one just for Wolfram alpha or something. What the integral 1 over x to the fifth plus 1. That's a very long integral there. Okay, so yeah, so Lucas, I think what you're doing is the thing where you switch the x's and the y's, and you isolate y again. So we can definitely do that. So if I flip each side, subtract the 4 over, and then we take the square root of each side, and this is where the issue happens. Because when you take the square root of each side, you need this plus and minus. And it's the fact that this plus and minus exists that means we can't choose just one thing. Like there's two possible answers to the question. And that's kind of where the issue is. And so x being greater than 4 isn't the issue. What I would say here, or sorry, so I the 4 isn't the important part here. The important part, is that anytime you choose a cutoff, you need to do that horizontal line test and see if you can get two values of the function. So the issue with your x less than or equal to 4 is you're talking about this zone of the graph, but I could draw a horizontal line that hits it twice, so that's not good. What I would do is say, draw a line here at x equals 0, and now if I'd say x is greater than 0, any horizontal line I draw out here only hits it once. Same thing, I could also say x is less than 0, and the same thing is still true. So that's how I would think about this question. Okay. And so you don't have to do 0. You could say, like, draw a line out here at x equals 4, but you would want to be greater than or equal to 4, because then your horizontal lines are okay. Oh, for this thing? Yeah, inside... Well, inside we need to... So the plus or minus on the outside still saves us. We could still have an x less than or x greater than restriction as much as we want. But yeah, there's that extra little annoyance where we can't take the square root of a negative number. So If we flip each side, we get x is less than or equal to 4. Oh, yeah, okay. Oh, so that's where you got the x less than or equal to 4 thing. Root 4? Oh, and Christmas, I'm sorry, I didn't even address you. Trig, yeah. If you are still here, but there's a little bit of a queue going. And Luke, I'm going to need to move on from this question soon so I can start to get through the queue here. But yeah, Chris, if you know what your question is, I can add you on. And Xerxes, your professor asked you to help solve the Koletsk conjecture. I doubt that. Welcome in though. No, Sock Creek, we're not doing imaginary numbers, so you're pointing out a valid thing. But Country Maker, yeah, the NCR flag. I love Fallout New Vegas. But okay, Lucas, before I do move on though, that is a good spot to see that x should be less than or equal to 4 here. It's a slightly separate issue from the inverse function because of that horizontal line thing that I explained. But it is related. So you might want to say x less than or equal to 0 or something like that to make sure you avoid that horizontal line issue. But yeah, good spot on that. Question on algebraic topology. Oh, I'm sorry, Mikav. I haven't studied algebra, much less algebraic topology, or I haven't studied topology either. So your favorite Fallout? Same. X should be a 4th. That makes way more sense if x is a 4th. I messed something up. Oh, I didn't flip the right side. I'm sorry. Okay, so x should be less than or equal to 4th because I flipped each side in this step, but I forgot to flip the right side. Thank you, Sock Freak. No, like 4 minus x. Shoot, wait, so did you get a different thing for this part here, Lucas? I think this thing is right. BF math when finishing grad. HS math. Oh, I get HS math when finishing BS math. This implies one can fully grasp BF math. You know, hopefully. Hell no. C instead of B. Oh, dang. Okay. Yeah, like at this point, I'm gonna move on, but if you want me to talk more about one of these problems, like I will absolutely go back through and do any of the problems on that screenshot, and I can get back to you in Discord if you have to like leave before I can get back to you. Or like you can post in that Discord thread too, and I'll like see it. Okay. So yeah, Hudson. Oh, good. You're still here. Thank you again for your patience. It's getting late here. No worries. T dx dt plus x equals root 1 minus t squared and x of 1 equals 0. Okay, so this can be solved with the same procedure here. Let's divide the t out. The answer to your problem is 1/2 t arc sine t. Okay, that seems like a reasonable answer. Let's get the integrating factor again. It's e to the integral 1 over t dt. So we get e to the ln t, which is just t. Now let's set up our equation, this time for x. Yeah, it's a good thing x is inside the radical, that's true. So it's the integrating factor t times the integral of the integrating factor times whatever function's over here. Yeah, so that's where our inverse trig is coming from. Okay, so we have to contend with, let's just do a little like side problem here. We have to contend with the integral t root 1 minus, that's not a minus. T squared over t dt. First thing, those t's can cancel. Actually, this is just the definition. I think we could probably show this integral with taking t equals to sine of u. It's one of those trig subproblems. So dt is cosine u du. So our integral would become root 1 minus sine squared u times cosine u du. And root 1 minus sine squared, Pythagorean identity, well, we'll get root cosine squared. Really? I'm not getting inverse trig, actually, now that I look at it. Oh, once we unsub, maybe. We end up with the integral of cosine squared u du. It's a good side of math, no flux or curl stuff. I love that stuff, but I don't understand it. So we have cosine squared u. We can use our favorite double angle identity here. I'm going to say cosine squared is 1 plus cosine 2 theta over 2. Okay. I'm saying cosine squared is equal to 1/2 plus 1/2 cosine 2u. That's just a trig identity. And this we know how to integrate now. We get 1/2 u plus 1/2 cosine, sine. Oh, and it's a chain rule. We multiply by 2. 2 times 1/2 is 1. So we get just sine 2u. Now we need to unsub. So we get 1/2 arc sine u. Plus sine, oh, that's not good. How do you deal with that? Oh, I see. We can do a double angle. Me Machine Rex. A lot of them are just being posted into the text of the YouTube chat. So I'm just like writing them down on this page, but yeah. Sorry, I really wish I could show the YouTube chat on screen, but there's a Twitch policy banning that exact thing, so there isn't much that I can do about it. Cosine, arcsine, u. Okay. If it's bounded less than, I don't think we have a bound. I don't remember. But here I did the sine double angle identity. So I split it up like this, and this we can simplify. So 1/2 arcsine u. Sine of arcsine is just u because those are inverse functions. Cosine of arcsine u. Well, arcsine u over 1 is equal to some angle theta. We can draw a right triangle here. Name that theta. Sine is opposite over hypotenuse. So opposite is u, hypotenuse is 1. And by Pythagorean theorem, the remaining side is root 1 minus u squared. So cosine of this right triangle must be adjacent over hypotenuse. So just root 1 minus u squared. Did I mess up the unsubbing? These should be t's. I'm sorry. At this step, things became t. That's stupid mistake to make. Okay, there we go. How do you know to use the trig stuff? It's a trick that comes up pretty often. You just kind of have to learn it, unfortunately. The procedure is that when you have what is that? It's on my okay, never mind, I'm sorry. The procedure is when you have cosine or any trig function out here of an inverse trig function, you can simplify it by drawing a right triangle. So you just remember that an inverse trig function is just an angle, and cosine of an angle is something. So if you know that sine of some angle that we'll name theta, sine of some angle theta is equal to t. And that also means that theta is equal to arcsine t. And sine is also opposite over hypotenuse. So you can use that information to draw the right triangle that I did. Just draw a generic right triangle, name an angle theta, it doesn't matter which one. And then whatever is here is your opposite over hypotenuse. So t is the same thing as t over 1. So t is opposite and 1 is hypotenuse. And then you figure out the third side of the Pythagorean theorem. Like, these steps are always the same. And now whatever trig function you have on the outside here, you just do that. So cosine is adjacent over hypotenuse. So you take the adjacent to theta, root 1 minus t squared, divided by a hypotenuse of 1. The third side is Pythagorean, like a squared plus b squared equals c squared. We don't know what a is. B is t, c is 1. Yeah. Superior the night, or superion the night. Nice. Multivariable calculus is pretty cool, though. Got it? Okay, nice. So yeah, once you know the third side, we just take cosine of this right triangle, and we get root 1 minus t squared. Yeah, this question involves a lot of legwork, unfortunately. But the entire goal of this side work in green was to figure out the result of this integral here, and we've now done that. So let's plug in what we just found. And then just to make it a little bit prettier, I'll distribute out the t. 1/2 t arcsine t plus 2t squared root 1 minus t squared plus c. We do have our initial condition to contend with. Hey, Pablo Lopez. Does that match the answer that you said? It nearly matches the answer you said. Not quite, though. Oh, I messed up my, I made a mistake in the integration. When I integrated 1/2 cosine 2u, I multiplied by 2, but I should have divided by 2. There should be a 1/4 out front here. My bad. And that 2 becomes a 1/2. Now, I also have a t squared right there that you don't have. Like that one. Did I mess that up too? Or... Huh. What career am I setting for? I don't really have a specific career goal, to be honest. I'm actually not even a student right now either. I just do the stream for fun. I've been a tutor at like a tutoring center, but I still don't know what I want to be when I grow up. I'm gonna plug this integral into Wolfram because it's not quite matching what you're saying the answer is, Hudson. I think that, did you, see, no, Wolfram agrees with my answer though for this part. So I haven't plugged in the initial condition yet, but Hudson, the issue that I'm trying to figure out is I have a t squared right here, and the thing you typed in chat doesn't have that t squared. Did you maybe leave that off by accident? Because I think the t squared is supposed to be there. And then once we can verify that part, we can do the initial condition. No, it's not. Unless professor made an error, it's not. Really? Ashton, do I know linear algebra? Not really. I'm sorry. I've taken a class in it, but it's really... My linear algebra knowledge was really bad. Okay. When in doubt, give Wolfram Alpha the differential equation. So I feel like it's supposed to be there, but I don't want to say there's a mistake in the answer key unless I'm sure. Frickin' Wolfram, I am wrong, I guess. I messed up the integrating factor. I must have. Oh, you divide... Oh, no, 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 no. You divide the integrating factor. Oh my gosh. I made a mistake on the last one too, I think, Hudson. I was saying you take this integrating factor, you multiply it. I forgot you divide it. Oh, what a silly mistake. So yeah, it's like 1 over 2t like that. And then that t squared goes away. Okay. My bad on that, Hudson. So I did make a slight mistake in the last one that we did too. The formula is you divide by the integrating factor. And that just slipped my mind, I guess. But the good news is that now I have the right result differential equation. We just need to plug in the initial condition here. X of 1 equals 0, so let's take the thing we got and plug in 1. 1/2 arcsine 1 plus 2 root 1 minus 1 squared. Oops, that is c divided by t plus c over 1. Okay, so 0 equals 1/2 arcsine of 1 is pi over 2. Plus 0 plus c. So c is equal to minus pi over 4. So that means our final answer should be good. It matches with what you got. I keep clicking the wrong thing. 2t arcsine t plus 2 root 1 minus t squared minus pi over 4t. And that's what I'd say. And so that's how you get the final answer there. Sorry about that, but I hope this makes sense now. That was very impressive. No one could get this one. I guess to be fair, I didn't get it until I put it into Wolfram Alpha, but I appreciate it. It's pretty procedural. It's just not messing up the steps is the issue, but it's always the same steps. Okay. Yo, Zappin, hey, can you do a problem for me and tell me I got it right? Yes, but there's a bit of a queue. So I'm just about to get to this relatively short question from John. And then I think Jaden had one that I haven't seen posted yet, and then it would be you. So I'll add your name onto the list here. If you want, feel free to post it. I'll copy it down and I'll get to it once I can. I'll type John's name in chat here to say that I'm addressing your question. So John was curious about the domain and range of, you have to say like z equals a function like this. And John was asking if it works basically the same as in the two-dimensional case, and the answer is yes, it is more or less the same thing. It does look a little bit different though, but we can kind of do the same procedure. So the things we have to worry about in this function are dividing by 0 and taking the square root of a negative number. We can address both issues at once though by looking at the condition 4 minus x squared minus y squared. We can require that this thing be greater than 0. So that assures we're never dividing by 0 and that we're never taking the square root of a positive number. A negative number, my bad. And so we can subtract the 4 over, minus x squared minus y squared greater than negative 4, multiply everything through by negative 1, which flips the inequality. And we find that we're basically allowed to plug in values that are within a circle of radius 4. Or, I'm sorry, it's radius 2 because it's square root of 4. But the border values are not acceptable, but anything inside of it is acceptable. That's the domain. X squared plus y squared is less than 4. And then the range of this, let's look what we have. We have 1 over, it definitely has to be a non-zero number, or it has to be positive. So it can't be negative, it can't be 0, because we're just never going to get values like that out of this. And so when x squared and y squared are at their biggest, we get something that's very close to 4. And when x squared and y squared are at their smallest, which is, I guess, 0, we will get 1/2. Wait, what? Infinity. Okay, Justin, that's what I think it is. I'm trying to justify that. So wait, yeah, when x squared plus y squared are very close to 4, we get 4 minus something very close to 4. So we're dividing 1 by a very small number, so that blows up to infinity on one end of the interval. And at the smallest, or when x squared and y squared are, I think, very close to 0, isn't it to infinity? Or 1/2? I 1/2 feels right if we let x and y be 0. Because we can't really do any smaller than that, and that gives us a value of 1/2. And I guess that's inclusive, isn't it? So I think that's the range of that. Zap in. Let me just take a quick look at your questions, tell you if I can do it or not, just so I don't waste your time. Prove square root of xy is less than or equal to x plus y over 2 for all xy greater than 0. You don't have to actually prove it. I just want all the possible ways to prove it. Direct contradiction. Oh. So prove the geometric mean is less than or equal to the arithmetic mean for all non-negative reals. I'm not confident that I can do that. I think there'll be someone around in the Discord who can do that. But I'm not sure. I'm sorry. The goat, can you do an inverse Fourier transform of a constant and show that it yields the Dirac delta? Maybe? I haven't done Fourier transforms in a minute. I don't remember the Dirac delta function is either. I've definitely heard it. I think I've worked with it, but... Let me just look at that quickly and tell you yes or no. I do remember these. I remember working with these. I don't... I don't think I'm going to know that direct delta thing for the plot. Or, oh, you're talking about Fourier. Yeah, no, I'm way off. I'm sorry. I don't think I can do that one either. The go. A Fourier transform. Yeah, I never even heard of that. I didn't know that a Fourier transform on that would even do anything. So I'm sorry about that. The go. I don't think I can do that. Okay. So it was just John's question. Hopefully if they check the recording, they'll see that. Jaden, are you still here? Did you ever post your question? I don't remember seeing it, but let me check if I missed it. I'm going to scroll up in the YouTube chat. I don't, Jaden didn't post their question. I'll type their name in chat. Flux 101, can you explain the concept of branch cuts in the context of complex analysis? I only sort of understand them. Can I maybe find let me see if I can find one of Penn Center's VODs, because I definitely remember that's where I learned it from. It has to do with there being like I can't think of the words right now, but oh, did Penn Center not highlight the class? Oh no. Oh, is the complex variables class just gone? That's a shame if it is. Let me see, is there a collection? I don't think he did. I feel like he saved it. Oh, maybe not. Dang. Okay, well. How are we talking about it? It basically it's because if you have e to the I theta, it's the exact same thing as e to the I theta plus 2 pi. Like you can always do one more for any point on the for any complex number in polar form, you could always do one more revolution around the circle and get to the exact same point. But to make a lot of things work, you have to just look at one. You have to kind of like arbitrarily restrict like this thing. You just want to ignore its existence. And where exactly you do that is called your branch cut. And so I think a popular one is minus pi. Like you only work on this integral for your possible values of pi. And that branch cut, like your branch cut then is right there on like the negative x-axis. And you would go from negative pi around to positive pi. EW or EDWD. I don't think I can do that one. I'm sorry. Who's asking this question? My knowledge on is limited. Wasn't basically we had a branch cut there, multiple branch where you could have a valid theta. Yeah, superior. That's my understanding too. And so when you take the arg of a complex number, is it capital A arg is on your branch cut? And then maybe lowercase a is the general? I might have that backwards. But like, the argument is just like, you know, the angle the function makes with the origin. And I think there's a distinction where they're like capital A means you're working on your branch cut, like in that interval, and lowercase a means you do the generalized. So whatever angle you get, say pi over 2, you add 2k pi. So that's like, it comes up with derivatives too, I think, and certain other things like that. But I don't have a good enough understanding of complex analysis to really speak more on it, unfortunately. Ludican, how's your day going today? It's going well. How about you? Thanks for asking. Yeah, Blux, thank you for the question. Showing a math lecture in 15 minutes. Oh, nice. What's the lecture for? Gonna get a cough drop. Calc 2? Ooh. I do enjoy me some Calc 2. Alright, well, we got through that queue of questions. Oh, we never did figure out this Flux one, did we? This one is really bugging me. This was a question someone asked towards the start of the stream, and I had to just move on because I wasn't figuring it out. I think I'm still not, but... We do a little bit of Googling, though, while we have some downtime here. Hmm. Okay, I'm glad not the only one who's struggling with this. I don't know, I think I'm going to go back to doing the physics setting. Isn't really homework. Have you worked on any in math? Any what in math? Maybe you forgot a word there. Oh, research in math. Sabrina, I see your question too. I'll answer in a second. So yeah, research in math. So I have a bachelor's in applied math, and the last year of my bachelor's, I was a research assistant for one of my professors. We were working on two projects. One was applying the SIR model, which models the spread of a disease, onto viral social media trends. My role in that was using MATLAB to try and figure out what parameters would fit the data that we had. And the other project was computer science. It was on a routing algorithm in ad hoc networks, which is like if you have a bunch of just like generic devices that can connect via Bluetooth. Say like, you know, imagine like you have like a you're at a concert and you're trying to send a message to your friend. Theoretically, if everyone had the same app, you could bounce your text from one person to the other, or like you bounce your text to one person, they bounce it to like everyone in a radius around them, that those people that bounce it and everyone in radius around them, and like it spreads out like that. It's about that, but we're finding a more efficient way that doesn't waste as much battery as just everyone always sends the message out to everyone in a radius around them, because that is a waste of battery and all that stuff. And so my role in that was to do simulations on the algorithm that they had. Career-wise, I never really worked in math unless you count tutoring. To what you said there, Obi. And so Superior, the explanation of flux, you generally learn about it in multivariable calculus. And maybe the intuitive explanation that I like is, imagine that you have a river and you represent the flow of water through that river with a vector field. So, you know, I imagine things would generally be pointing to the right, but they'll be a little bit like up and down, weirdly. And say you're interested in measuring the flow of water through a part of the river, you can draw any surface, like two-dimensional surface you want. Like say I'll do like a tilted square. That's not tilted. Just like, you know, some like square that's tilted in 3D. It doesn't matter what. In the flux measures, the vectors that go through that surface and how well they line up. So like, I'm not doing a good job of representing, but like this square is at an angle, and so that is also kind of affects things. That the flux is higher when things are lined up with each other. You know, the physics book that it's used a lot in electricity and magnetism. And this book that I've been reading out of has a pretty good explanation of it. If I can figure out where. Here, flux. Here we go. So I'm basically just repeating this book's kind of explanation of flux, but like at this figure at the top here, these vectors that represent the river, and this kind of square are the things that you're measuring. It's like the kind of like almost like net or something you could imagine that you're measuring the flow of water through. So if you hold it perpendicular, you're going to get the most water coming through it. Or sorry, if you hold it like straight up and down, you have the most water coming through it. If you hold it side to side, you're not going to get any water flowing through it. Or maybe some, no, it'll basically be none because it's 2D. And if you have it at an angle, you kind of get somewhere in between. You do a dot product of this area vector and the flow of the river. So it's going to be like cosine of 60. Yeah, the square is rotated in 3 dimensions, Superior. Yeah, so that's the idea of what flux is. So you can do the exact same thing in 2 dimensions, like the problem we were looking at. But they're just kind of hard to set up. If the is nice, like this one on the left, you can literally do the area times the vector field, and it's pretty simple. But if it's not a simple situation like that, then you're kind of done for. Not done for, but you have to do a lot more work. I think I'm gonna delete this one though, because I don't think I'm figuring out. Oh, I don't think I'm figuring it out anytime soon. So what I've been doing in the downtime is studying some mechanics, and I was working on 3.9 here. Yeah. So you have to do some parameterization stuff, and it wasn't clean. Okay, so I want to get a formula for this thing in terms of y. We need to figure out where theta is, though. That's a right angle. Do we need to extend that line out here? Someone make a triangle like that? No. Well, I guess what we don't want that right angle though, do we? We want that right angle. And where is theta here? Oh, I want to figure out what the y component of this velocity is in terms of this theta here is what I'm trying to work on right now. Okay. I think I see it because if that's theta, this is also theta. But that's a right angle. So this angle here is pi over 2 minus theta. And this angle up here is just theta. Okay. So our y position and h is just r sine theta. V is going to be multiplied by cosine of theta, funny enough, times time minus 1/2 gt squared. I think that's the formula we want. So r sine theta is the starting height. V cosine theta is the initial y component of the velocity. 1/2 gt squared is the normal acceleration due to gravity. Does this make sense? So if theta is 0, then we have 0 starting height, and the initial y velocity is the highest. Okay, good. I think this makes sense then. Some bits become unstuck from... What should theta be so the mud reaches the maximum possible height above the ground? So it flies through the air. Okay, so the maximum height... I think the book just gives the formula for that. I could derive it again, but I don't feel like it. Oh, we might have to derive it again. That was having you posted a question. Let's see. Oh, an E&M question? We'll try it. My E&M is pretty weak. I've been studying it, but I'm not very good at it. Am I missing a piece of the question here? What forces are acting on sphere B? Okay. No worries. Okay, and this is page 1 here. Thank you. Oh gosh, you got a lot going on here. No, it's just, that's gonna be too hard to read. Let's just make it big. Okay. What? There we go. Okay, so since we're going to determine the value of vacuum permittivity epsilon naught, sphere A is non-conducting with charge plus Q, and is attached to an insulating rod. Sphere B is non-conducting with charge plus Q and has mass m. Sphere B rests on an insulating platform of negligible mass that is attached to a vertical ideal spring with spring constant Ks. Sphere B and the spring are initially at rest. Sphere A is then brought near sphere B without touching when the center of the sphere are separated by vertical distance h. The spring has been compressed by a distance y as shown in the figure. The students measure y for different values of h. On the following dot that represents sphere B in the figure on the previous page, draw and label the forces, not components, that are exerted on sphere B, each force being represented by a distinct arrow starting on and pointing away from the dot. Okay. So I can probably handle this, I think. I think I understand what's going on. For part A here, we're focusing on sphere B. So, sphere B is experiencing a force. It's pushing, like, sphere A is pushing sphere B away from it because they're both positively charged, so they're repelling each other. But the spring is pushing it back up. And do we get to neglect gravity here? Maybe we probably don't. But they don't give us the mass, do they? That's probably built into the spring constant, I guess, if it's vertical like this. No, they do give us mass. Okay. So I'm glad I thought about that. 2 balls on a glow plug. Yeah. Hey, Tyler. So I think pointing up, we have the force of the spring, which we can maybe call F sub S. Pointing down, we have the force due to gravity plus the force due to sphere A, the electric force. And I think that's everything that's happening for part A. Oh wait, each force... Okay, well, they're being oddly specific with how they're asking for this. I don't know how... Like, these are both pointing down, so I don't know what exactly they want. They want a distinct arrow for each force. So maybe like that? I don't know exactly how we're supposed to draw this. Maybe they're supposed to be overlapping and just use different colors. So I'll make that one F sub G, and then I'll draw another one in green. F sub A. Derive the relationship between y and h to show that y equals all of that stuff. Okay. And I think what they want us to do here is, we know the sphere B is at rest. So these forces should be balancing each other. So I think we can make the statement that F sub S is equal to F sub A plus F sub G. And the force due to a spring, if I'm not mistaken, is the spring constant, which they call K sub S, times the displacement Y. And that's it for the force due to a spring. F sub A, we can use Coulomb's law here. So 1 over 4 pi epsilon naught times... That's not it. The charge of A is small q, the charge of B is big Q. So small q times big Q, they're both positive, over r squared, and here r is capital H for the distance but between them. And then we have to add in the force due to gravity. So sphere B has mass capital M. So plus capital M gravity, and that's it. The relationship between y and h. So the only thing that's left to do here, we want to isolate y, and we're going to find it'll match exactly once we... All we have to do here is divide everything through by K sub S. Wrong epsilon. So yeah, that's how you get that Sapin. Let me know if you have any questions there. No worries. It actually helps them with a physics problem without going and for 20 minutes. That's progress for me. Okay. Big improvements here, I like it. Big brain. Hell yeah, Tyler. All the studying of physics isn't quite for nothing, I guess. Maybe back later. Maybe another hour or so, Zabin. Do I know Python well? I know the basics of it. I've written some things in Python. Python midterm tomorrow. Okay. I bet I can figure out what you're doing as long as you're not in like some super advanced class. Raps? Oh, like a rapper? Put the crickets in the grass? I never mind. You're saying, sorry. I thought raps is like a Python thing. I was like, really? It once you come back, just go ahead and post your question, and I'll try. No, Tyler. We're talking about Python like the coding language. It's often used to do computations with, so it's relevant in math, but there's no like special thing called Python there. I want to figure out when this thing reaches the top, and so we should wait. Wasn't there a way to use? Oh no. We want v sub y. V sub y is v cosine theta minus gt. We would set that equal to 0 and find that t top is v cosine theta over g. Can you find the goatiest lecture videos known to man? Strictly Python. It's a basic. I mean, I can look. I don't know of one offhand, but I mean, I guess what's preventing you from just doing that yourself? Because I will just type in Python lectures to YouTube and look for that there. So if you want to post like a prompt or something, or like post to some code you're trying to troubleshoot, I'll do that. But I don't think I'm going to look through YouTube for a lecture playlist because I don't really have one offhand, unfortunately. Need to get into coding. A lot of money to be made there. Yeah, I wouldn't say it's easy to get in, but if you can get in, you'll be cruising. Okay, here we go. You've heard coding is saturated. Um, I don't know enough about like I guess like the job market there to actually say for myself. I'm just basing off my personal experience of graduating with a bachelor's in applied math and minor computer science and not being able to even get interviews at like coding jobs. So I got like a single interview or something like that, and then they ghosted me. Um, but I applied to a ton of jobs and just like got nothing done. So no, bachelor's in applied math as like the major, and then a minor in computer science. Okay. Yeah, exactly, Obi. Um, and so I think I needed to, I was looking back on it, I think like I could have done more like projects or something to actually demonstrate my like coding knowledge more, but I will let you work for me. Thank you, Spetri. Sine theta over G. Okay, so the one on the cosine theta equals 0 gives us theta equals pi over 2 and 3 pi over 2, neither of which are particularly helpful. On the right, r minus 2v squared sine theta over G 0. Very good conditions, but no health insurance. You know, you drive a hard bargain, but I guess beggars can't be choosers. R times G over 2v squared, right? One of my good friends codes and does security testing for the government. One of the wizards. You're a math wizard, he's a computer wizard. Oh, nice. John Smith, answer 2018 IMO P6 next. I'm okay. I don't know competition math. IMO problems are pretty insane. Superior on the night. Shouldn't there be a 1/2? Oh, dang it. Yeah, Superior from this. I forgot that there should be a 2 right there. Good catch. Explain Schrodinger. I don't have audio. I don't know Schrodinger, but I'm not gonna, even if I did, that sounds like something really complicated that I can't just explain in text. Schrodinger, sorry. I'd let Dom be my boss. Oh god, dude. Imagine being a boss and being responsible for employees. That sounds kind of terrifying. Explain Isaac Newton. An apple fell on his head, and then he invented gravity. That's Newton. Sophisticated idea of quantum mechanics. There we go. There's an explanation of Schrodinger. I assume there's like a Schrodinger equation or something is what the person actually means. That actually, yeah, he meant to calculus as a side quest, basically. We can assume that v squared is greater than gr, and that just means that this arcsine is valid, like it's defined. Because you can only plug things between -1 and 1 into arcsine. Or is that no? Yes. Yeah. I know he didn't invent gravity. I just like saying that he invented gravity because it's kind of funny, the idea of inventing gravity to me. Like, but you're right. Actually, I didn't know about the idea of gravity. I assume that I guess I assume that he was the person who thought of gravity as an idea, but evidently not. I don't know. People have, I guess, always known that stuff falls when you drop it. Maybe that's I don't know. Number 9. I feel like I nailed this one. I'm just gonna look at the answer. Aha! All right, let's actually read it from the start now. Height r plus r sine theta. Is it? Oh, that's okay. That doesn't matter. I see what they're saying now. They were considering, okay, it doesn't actually matter. It's just a different starting point. They were saying, oh my God, please. They're measuring the starting height as from where it flings off to the ground, which, so you have to add an extra r for this distance here. But I was just measuring it from here to here, which I think is also fine. Just a different choice of origin, I guess. People knew things. Yeah, okay, that's fair. Physicists had the idea of attractive forces for a bit before him. Okay. From together using calculus, which he meant to model a relationship using differential equations. Okay, that makes sense. What about Leibniz, though? We just don't talk about Leibniz, I guess. Yeah, their R here goes away once they take the derivative anyway. Leibniz made better notation by several orders of magnitude because he was a math teacher, not a physicist. He grudgingly made his own notation that only he could read. I definitely believe that the Leibniz notation is probably better. Hey Finn, what's my background in math? I have a bachelor's in applied math, minor in computer science. Graduated maybe 5 or 6 years ago. And I used to be a tutor at a community college. Oh, I didn't actually get the maximum height. Did they ask for the maximum height? No, they. Oh, dang it. I missed there's a part 2 to the question. What is the maximum height? I didn't look that closely at the actual answer, so let's actually go through and do that quick. So we know what theta is, so we can just plug it into our formula for y top. R sine arc sine rg over v squared plus v squared cosine squared arc sine rg over v squared over 2g. R squared g over v squared Cosine of arcsine. RG v squared root v to the fourth minus r squared g squared. Disgusting. And we're taking the square of that. So it'll be v squared v to the fourth minus r squared g squared over 2g. In your opinion, what was the hardest class you had to take in applied math? The two classes that always come to mind when people ask me that question is discrete math, because I'm just not good at discrete math, and my second semester physics class on electricity and magnetism. I think those are the two classes that are like most memorable to me in being difficult, but it really depends on you as a person and the professors at your university. I don't think there's really, it's like that's the hardest class in my experience, but what other people experience as the hardest class is going to be way different. The professor is really what makes the class easy or hard to me. I don't think there's any use in getting common denominator here. Maybe there is. Honestly, I think E&M was made harder because oh, never mind. There isn't a use. Maybe there is. Because it didn't have multivariable calculus as a prerequisite, which means they couldn't use multivariable calculus, and that makes E&M really lame. Haha, this guy's hilarious. No, I once had a retired physicist tell me I was going to solve the three-body problem. Wow. I think that I know there's just like a Netflix series about this that everyone was talking about, but I think the three-body problem is trying to model, like, if you have like 3 stars in space or whatever, I think it's a big problem math, like, or in physics, how do these things move under the influence of gravity when you have 3 things all like affecting each other? I think that's what the three-body problem is. Question mark. Hey, Bib, I personally hated real analysis. It was very interesting, but the first time I found math hard. Right. I specifically avoided any type of class that involved proofs. I couldn't avoid it sometimes, but I avoided real analysis. I avoided topology. I avoided abstract algebra. I avoided all that stuff. So I probably would have answered with one of those if I actually took them. What was the point in doing this? I thought there would be something simpler here, but there really isn't. You're my uni who was convinced he was going to solve the Riemann hypothesis. Oh, wow. You avoided topology, don't find it interesting at all. I mean, I don't know anything about it, to be fair. I just can't imagine I would find it interesting. I see you're saying as well, Superion? Okay. Yeah, the TV show, it came out recently and it's pretty popular. I am getting the wrong power of V. Yeah, that one, Viv. Yeah, it's probably going to drown out the Google results, unfortunately. I don't know where to go to find an actual, like, scientific explanation. What did I plug into the wrong thing? Trying to get into proofs a little bit. They're definitely interesting. A lot of people feel that way. I personally don't. A lot of proofs. I sometimes have enjoyed proofs, but my default is I usually don't enjoy proofs. Yeah, I remember like everyone was talking about that TV show for a good like month or two. Proofs are in essence of purest mathematics skits. Yeah, that's why I don't like them. I did actually enjoy my college geometry class. That was pretty proofy, but they didn't ask you to do ridiculous geometry problems where you have to know the most vague theorems. It was basically just proving the geometry stuff in Euclid's elements, and then going a little bit into non-Euclidean geometry. And so that was actually kind of cool, but and some of the proofs in Zach's class were cool too for the real analysis, but I generally don't like them. He had to take an intro to proofs class twice. It was the most basic proofs class, but cooked the second time. Yeah. Unlike math is not necessarily better with purity. True. In all fairness, though, the most I really know for proof is 18 is something basic like proof x squared is even given x is even. Okay. So let's learn so your opinion changes. Yeah. And I feel like you're going towards like number theory type of proofs too, which a lot of people love, but that's one of my least favorite things, I think. You love meth? It came to the right place. Some people... I am known as Don Does Meth among some people, so... What did I find harder, Calc 1 or Calc 2? That's a good question. So I think Calc 1. The first time I took a calculus class was in high school. I took AP Calculus BC, which basically is in 1 year of high school, you do Calc 1 and Calc 2. And my experience in that class was I struggled super hard for the first like month or two, but I basically just studied every day until I finally figured out what a derivative actually is. And then the rest of calculus kind of followed from that. So I guess I found Calc 1 harder because the Calc 2 part kind of flowed after that. Calc 2 has a lot of really weird tricks to learn though when it comes to the more advanced integrals and power series. So I wouldn't say it's a walk in the park. Suna, I still struggle. I mean, I still struggle with the problems too sometimes, but yeah. He isn't just called Don because of his name. Yeah. Dude, in Breaking Bad, I always think like how cool it sounded when they called that one dude Don Eladio. It just sounds cool. Found Calc 1 easier than Calc 2, mostly because I did Calc 1 in high school and the pace was slower. Spent a lot of time on every concept compared to a 4-month college course. Yeah, I mean, that's why I went like to my high school experience, like trying to figure out the first time that I was learning calculus, what it felt like. How can it be to comprehend a derivative, right? I mean, derivatives do get a lot more complicated when you go to like Calc 3, but yeah. I'm doing well overall. Thanks for asking, Suna. How are you doing too? It's kind of been chilling, still working on this physics stuff. I just got this tablet thing to write with. You know, since you like Osu, I haven't played Osu in years, but I'm half wondering if it's worth trying to play Osu now that I have a tablet. I always just use my mouse before. It's pretty nice. It's taking some getting used to, but I think I'm starting to get the hang of it. Calc 3 is your personal favorite, easiest of the bunch. I've had friends who said that too. For me, it was kind of the same as Calc 2. Like feel a bit unusual. Oh, do you use your mouse as well when you play? It's October. You should play scary games. Uh, Phasmophobia is doing a Halloween event. I think starting on October 28th. So I do want to do that. I'd love to play Outlast Trials as well again. But I want some friends to play it with, and none of my friends have it, so I don't know about that. Scary Osu? Just do like an 8-star song or something? Overwatch is doing Halloween event too? Oh, okay. And Calc to the Taylor Series McLaurin series had me on a rope. Oh. They can ask some really tricky questions with those, yeah. For me, Calc 1 was only difficult until I understood what a limit was. Then a lot of the derivatives fell into place. I don't know what it is, but integrals are pretty tricky for me. Yeah, the techniques for integration are really tricky. Granted, they do get more complex in Calc 3, yeah. Erica, am I familiar with HSX? I don't recognize that acronym. HSC. I don't recognize that acronym either. HSC. I feel like I should know it. HSC. Homeschool Association of California? That's probably not it. Math. No? I don't know. If you tell me what HSC is, I might... Is it an entrance exam? Australian High... Oh, okay. No, I'm not familiar with it. If you have a specific question, I can try to look at it, but... It's the first time I'm hearing of it. Oh, so we take a shot of hot sauce after every mistake? Oh no. You can do that to get resistant to hot sauce. Dude, my problem with Osu is that when I played it, I would get bored if I played songs that were actually at my level, and so I basically only played songs that were slightly too hard. And I I would very rarely like actually beat songs. I would be taking a lot of hot sauce shots. You don't really beat them too? Okay. Like what stars do you do? If there's I don't know if there's a better way to ask that. I was normally around like 4, I think like lower 4 stars if I remember. For the songs that I would do. Why am I getting the wrong answer here? Oh, they make the cosine squared 1 minus sine squared. That is easier. I should still get the right answer. But apparently I'm not. Over v squared. Oh my god. Wait, no. I think I messed up my cosine maybe. Yeah, I forgot. The cosine should have... I forgot the v squared, I think. There should have been a v to the 4th down here. So that'll be v to the 4th. Get rid of that v. Just get rid of that one entirely. Play relax slot. Normally 5 to 7 stars and our relax 8 to 11 stars. Dang, okay. You're pretty good at it then. It's always the small mistakes, yeah. The funniest thing is always like when I start to make like 1 or 2 small mistakes and then I start freaking out and they snowball into like bigger mistakes. You can just like feel it going downhill. Oops. So we get r squared g over 2v squared plus v squared over 2g. So they're probably going to have a plus r on the end, but with my choice of origin, I'm not, I guess. But I'm not worried about that. It is there. I mean, I am like slightly wrong with that, but I don't care about that. 2v squared over 2g. Hell yeah. Okay. Oh, interesting. For that limit, v squared is about g over r. It's about 2r. Interesting. Okay. So that was number 9. Let's go to number 10. I don't know how many more in chapter 3 I should do before I move on. I think I've been struggling with them enough that I should keep doing more. I'm gonna give myself. I've been grading myself on these. This one, I'll be nice to myself and give me credit. Despite that flub of forgetting to answer the second part of the question. We should throw a ball to a friend who is a distance 2L away, and you want the ball to just barely clear a wall of height h that's located halfway to your friend. What angle theta should you throw the ball? Okay, well. Oh, there should be an easy way to do this, right? I feel like there should be a math way of doing this. Like, what I want to try is saying y equals some constant a times x minus l times x plus l. Or not, that should be t. Actually, no, this is stupid. I should do it the right way. So y is going to be v naught sine theta t minus 1/2 gt squared. I was just using the formula. What is the y at the top? So you want to let that be h, right? Oh, I'm not. Oh, shit. I wasn't showing my journal plus plus. Ugh. My bad. My max is v naught. Two G or just G? Just G. 2G. And we're gonna say that's equal to h. I come back later if the stream is still going. I'm off for now. All right, see you, Superion. Probably not gonna go for a ton longer. Like, 30-ish minutes. Hope you have a good day. If you're not back by then. I guess we also want x max. 2v naught squared sine theta cosine theta. Over g. How do we actually put these things together? Apple, what is 3 times 8? 24? No worries. Do we divide these two equations? Like, I'm not sure. You're just kidding, but I'm in pre-calc. Do you have any tips in general? Tips for pre-calc? If you have to do the unit circle, like if there's like a trig part of it, which my pre-calc class, like for my pre-calc class, it was like 1 semester of trig, 1 semester of pre-calc. The unit circle, if you have to like memorize that, what you can do is memorize just the first quadrant, and you can figure out what all the other ones must be. Like what the rest of the unit circle must look like just based off the first like quadrant. And I can talk about that more if you're interested, but I won't go into it if you're not. Do you remember what other type of things that you do in pre-calc? Honestly, I can't remember what my pre-calc class was like. I think we talked about like the end behavior of functions. I remember that. Maybe graphing rational functions. Just simple stuff like logs. Okay. Maybe the most general tip I can give is to actually pay attention to that stuff, because it comes up in a big way if you have to take a calculus class. Like, probably the most common issue that I see when I tutor calculus students is that they're not strong on the things they learned in algebra and pre-calc, and that can come back to bite you. So I would pay attention now if you're going to have to take a calculus class at any point. Yeah, exactly. So the stuff that you're doing right now, it's not going to feel very helpful, but it does become helpful later on. Sereno. I'll trig sine 1 over sine cosine. Oh wait, for the quadrants? For like what's positive and negative? I'm not sure what you mean with that, but I'm in calc right now, but I don't get how to get through all the trig. It never was my strong suit. I don't know how to get through all the steps. Yeah, the trig part of calculus is really tricky. The most common things that you need, I think, that's my reaction. I guess it's more like in Calc 2, but like it's really good to know the Pythagorean identities. So like sine squared plus cosine squared is 1. You can divide this thing through by sine squared or cosine squared to get what the other two are. So if you divide it through by sine squared, you get 1 plus cosine over sine is cotangent, and 1 over sine is cosecant. And if you take it and divide it through by cosine, you'll get tangent. Oh, what the hell am I writing? Plus 1 is 1 over cosine, which is secant. It's also really good to know the doubling of the identities, which actually I don't have them memorized. I just look them up, but like these first 4 identities on the left here are really good to know. Did very well in pre-calc, but that was because I was good at algebra, didn't even study for it, then calc 1 and 2 killed you. Oh, dang. And then beyond those identities, you really got to know the unit circle too. Unfortunately, trig it's kind of a lot. Oh, really, Sereno? I didn't even know that. Interesting. I've heard others that like Zach and maybe others, they verify them with complex variables. Or that's how they like remember them. I don't know how that works exactly though. So yeah, I'm sure to pronounce your name, but Twal? If you have any specific questions, feel free to let me know, but if you're just looking to like rant about the trig part of calculus, then I'm all ears, and I definitely agree that it's difficult. Best memorize all of them, the identities, I would be good. I'm good with the unit circle, I feel like if you know, yeah, so that's perfect with the unit circle. If you know the one of the quadrants, you can build out what the other ones are. Yeah, like honestly, I don't even have them memorized myself, but it probably is going to be helpful to have them memorized if you can't do like open books or open notes on your tests. I guess the other thing in a calc class is you'd have to know like the derivatives. So it's not as simple as just the two identities like I said. I guess if like you should also know things like sine derives to cosine. Cosine goes to minus sine. Yeah, the Pythagorean identities are especially important in Calc 2, because I'm not sure which calc you're in or like what part of calculus you're doing, but like if you have to do an integral of like 1 minus x squared, that uses a bunch of trig. So, and like you have to recognize that this looks like a rearranged version of sine squared plus, like I could take that Pythagorean identity and rewrite it as, say, cosine squared x equals 1 minus sine squared. And the fact, oops. Oh no, I'm hitting all the wrong buttons right now. And the 1 minus x squared looking like the 1 minus sine squared is a hint for how you solve that integral with trig. So there's things like that. That's why I'm saying that's good to know the Pythagorean identities. But if you're just like learning derivatives, you should focus way more on this type of stuff. ln derivative is very useful too. Yeah, knowing the derivative logs. So yeah, how I memorize the unit circle. All right, so like I said, or like the first quadrant, just memorize it, unfortunately. 1, 0, 0 radians. This is 1/2 root 3 over 2 pi over 3, or pi over 6 radians, or 30 degrees. Root 2 over 2, root 2 over 2 is pi over 4, or 45 degrees. And then this one over here is root 3 over 2, 1/2 pi over 3, or 60 degrees. And then finally, we have 0, 1 pi over 2, or 90 degrees. Dr. L, what are all the points between 0 and 2 pi such that sine of s plus t is equal to sine of s plus sine of t? Oh. I would need to think about that one, Dr. L. How does that identity work again? Sorry, just a quick detour. Cosine has to be 1 at both s and t. Is it just 0 for like s and t are both 0? Maybe it might be more complicated than that. Well, I went back to, I'll think about it more later after I'm gonna explain this to Apple. Okay, so Apple, this is the information that I say you, or at least for me, I just have it memorized. We can build everything else of the unit circle out of this. So the easy ones are like this one right here. Like we can just see that it's -1, 0 for the point, and the angle, it's 180 degrees because it's a straight line from 0. So that's pi and that's 0. If you don't remember the pi, then remember that pi over 2 is 90 and multiply it by 2. The other easy one is this one down here, because we can just look and see it's 0 minus 1. With now multiply that by 3 to get 3 pi over 2 radians, or 270 degrees. Finite derivatives is just when they ask for the proofs through limit definition for trig derivatives. Oh yeah, those limit definitions for the derivatives of trig functions, that's pretty terrible. Okay. So yeah, if you just need like that first quadrant of the unit circle, it's worth memorizing. Because now if we want to build out quadrant 2, I'm going to draw these same 3 spokes of kind of the unit circle here, something like spokes of a wheel, I guess. And the trick is that, like, these two are a pair that are higher up on the circle. Their coordinates are going to be the exact same, but we just need to flip one of the signs. So I'm going to repeat these same two numbers here, but we can see like y is still positive, but x is negative. So just make it minus root 3 over 2, comma a half. So that's what the point is. The angle, I see that like we have 90 degrees here plus pi over 6. It's just like a small angle there. So we can literally do pi over 2 plus pi over 6 and get 4 pi over 6, which is 2 pi over 3. And that's the angle in radians. Doesn't just switch the order each segment. I don't really mean by switch the order, but like your options are always root 3 over 2, 1/2, root 2 over 2, root 2 over 2, or 1/2 and root 3 over 2. Like those are always your options for what the coordinates are. So the angle is 2 pi over 3 in radians, or you can do 90 degrees plus 30 degrees is 120 degrees. So I get the coordinates by looking at like the pair, and then I get the angle by adding quadrant 1 angles. So I did 90 plus 30 to get that first one. All right, see you, Tlal. And so I think, for me, these like, that point right there is an easy one to remember because it's so similar to the pi over 4 one. Like, yeah, I have to do a lot less memorization there because that's just minus root 2 over 2, root 2 over 2. Hey, Anders. And then for the angle, I guess we do pi over 4 plus pi over 2, which is 3 pi over 4. And the angle is 90 degrees plus 45 degrees is 135 degrees. I'm running out of room. And then that last point down there, we like now these 2 points are a pair. So we use the same coordinates, but we flip the x coordinate, 1/2 root 3 over 2. And then for the angle, we do pi over 2 plus pi over 3 is 5 pi over 6. And 90 degrees plus 60 degrees is 150 degrees. So I only using the values from quadrant 1, I just built out quadrant 2 just by matching up the coordinates, flipping signs when necessary, and then adding angles. You can do the exact same procedure for quadrants 3 and 4 there. And if you get like, I've done this enough that I can get really quick with it. So like if I want to remember what this one down here on the unit circle is, I just think, oh, well, I'm going 3 pi over 2 around, and I remember what 3 pi over 2 is, and then I'm just doing a little bit more, which must be like 30 degrees. And so I know that like these two are a pair, so the coordinates are going to look like this one up here. And the angle is going to be 3 pi over 2 plus pi over 6. So I literally like do 3 pi over 2 plus pi over 6 in my head. And I know in radians that the angle for that one there. I'm trying to do in my head at least. 10 pi over 6 is 5 pi over 3? Yeah. Yeah, also. That's the advice that I have for the unit circle. And I would actually try and do this out in full at least once on paper to get used to it. What sine of 4350?
Well, I had to subtract 360 from it a bunch of times, but I don't know.
No worries, Apple. Thank you for the question. So Dr. L asked, for what values of s and t is sine of s plus t equal to sine of s plus sine of t? So, like, s equals t equals 0 is the obvious one. Well, yeah, between 0 and 2 pi. So I guess we can also say 2 pi. Does that work for, like, just pi? Where cosine is a negative one? No. Yes? Because sine is 0, right? So I guess pi works? But I can't see it being... I don't think I can see it being anything else. Well, what about pi over 2? Could that work? No, that's going to equal cosine, right? Maybe it's... I mean, I guess you can have it. They don't have to be... S and T don't necessarily be equal. You could have S equals 0, S equal... or T equals 2 pi, I guess. Okay, so that one's not true. Okay. If you graph it geometrically, it's kind of obvious. How do you graph it when there's two variables like that? Bisecting over right triangle. Hey, Revolution 2.0. I took the SAT, and I think I got an 1860. When I took it, it was scored out of 2400. Oh, I see that Eric with a D posted a question on Discord. Oh man, okay. It really helps me if you say something in chat when you post something in the Discord, because I don't always see it. If it's just in Discord. let's take a look at this person's question. Taking the SAT in 9 days, my science score is really bad. Oh, I'm sorry. I really don't know much about the SAT or the ACT. Best of luck to you, but yeah, I don't have a lot of like specific advice that I can give you. I'm sorry. Eli, hey, I'm interested in applied math. I have a bachelor's, which is great. The tension of the key, the tension you're feeling looking at the problem. I think the tension I'm feeling looking at the problem. There's a lot of lines going a lot of places here. Sounds good. Revolution, you too. Sorry, couldn't be more help. The components of reaction at D needed to support the load? What? Oh, Dr. L, I was thinking about your problem. I figured that you can have S equals T equals 0, 2 pi, and pi, but I don't know if there's supposed to be more. And then I noticed that this was posted in the Discord, so I stopped thinking about it. Aditya, I need help with the statistics of my midterm. If you want to pose a question, I can take a look at it. My stats isn't the strongest, but I can put it there in chat, or screenshot. If screenshots are easier, I have a Discord. I think this might actually be that bad to work out this problem, but I don't understand what this means. Is that, like, why is it at an angle? What force is that? The gravity should just be straight down, so I don't know. It looks like an applied force. That could be it. And that, I also don't know what the component of reaction at D is. Hey, Pen. Appreciate the lurk. Hope you're doing well. Probably gonna wrap things up in a minute anyway. Should I go to uni tomorrow or no? I mean, I don't think I personally ever missed classics. So I was feeling lazy. I always made a point of going, but I know a lot of like my friends and stuff just would take days off. So I don't know if you feel like you need it. Help solve for all the forces first, and the normal force is simply the force required to maintain equilibrium. I guess so, yeah. Um, we don't know the mass of the rod, I guess. I think it'd be very functional 3 hours of sleep. It's fair. Um, how does... Oh, man. But how does tension work? That's my other issue. The horizontal component of cable B must match the horizontal component of cable at A. Oh, God. Yeah, I guess you're right. I feel like this is maybe... I thought I could work out the tensions of this, but I'm realizing it's kind of complicated because you have like... There's torque involved, right? Where like this is the pivot. And the force due to gravity is like the length. Ah, man. The more I look at it, the more I feel like I probably can't do that. There will be torque if there's friction. Really? You need friction to have torque? I'm just like, what's the force due to gravity on this thing? That's what I was trying to figure. If there's a support here, doesn't that change things? That's why I was trying to think about torque. I think so, yeah, Mega. Um, oh, Lucas, you're still here. Are we all a bunch of nerds or a bunch of geeks? Yeah, I like Suna's answer. We're both. Um, because I can see like I assume I like Teradara's idea that this 400 Newton force is probably some like externally applied force, but we still need to worry about force due to gravity, do we not? And that's what I don't know. I don't know how to quantify that for this situation. But we could definitely draw a bunch of like an ABC triangle. Like we can just draw a bunch of triangles here if we cared to, but yeah, I mean, okay, it's probably more accurate to draw. Well, like yeah, gravity acts at the center, I guess. But if we're interested in the force on the end of the beam here, I don't know how that works. That's why I'm getting a little bit sketched out. Is d over 2 mg. The weight acts from the center of the mass, has magnitude mg, and points down. Right, Dr. L, but then part of that, I guess I want to ignore the component that hinge or whatever is holding up. But even feeling a bit down, like my mind is just chaos and I have more problems with remembering things. Why am I talking about this here? Sorry, I'm not laughing at you. I'm just like, so sort of like, why am I talking about this here? Is like, I feel that, but I hope that passes for you, I guess, Lucas. Should go to sleep. Fair enough. The force goes in the direction of the cable. Yeah. the quality of your sleep. Oh, okay. That could definitely do it. What's that? 7 hours of sleep. I mean, how much sleep you need is a pretty individual thing. The 8 hours a day thing is just like a general guidance. Take the cross product of every force acted at point A with vector AD. I think that would be a good starting point. A cross product helps here? How does the cross product help? So I'll devote myself to one thing for sure. Eliminate sleep altogether. No more you should go to bed. I mean, not having to sleep would be pretty great. Torque is he... Oh, really? Okay. And isn't torque tau? Well, we need to figure out the vector components first before we can do that. So the CA cable, that one's just pointing straight up, right? So we can just take that one at face value. But well, okay, tension in AC plus tension in AB is equal to the torque AD, I don't know if this notation is quite right, plus we need that 400 Newton vector. Like that, I guess? Like that's how we're thinking about this. It's a static problem, so you can choose your pivot point wherever you want. Then calculate the torque due to each force. The vector sum should be 0. It's been way too long since I've worked with torques, which I don't remember this. Like I think I would need someone to like carry me through each step of the problem here, or like it's posted in the Discord too. Someone might get to it, but like I don't think I can do this on my own. I think I'm closer to just like calling in, not doing the problem, to be honest. Hey, Scorpra. Um, I'd like to be able to do a problem like this, but I just don't remember how this stuff works well enough right now. Even exercise, yeah, basically a Territar. I appreciate you like trying to help me out, but I would need to be spoon fed basically everything here, so I don't really want to do that. How's it going, Sport? You caught me like right at when I wanted to end here, but yeah, I still don't know quite know what to do with 10 that I was working on before. Been lurking? Oh, okay. I'm glad I'm not just like about to end right as you like get here. It's good to hear. Yeah, I think we'll call it there. Number 10 here, I'm gonna have to keep on thinking about. So Territory Nanos is here on YouTube. I appreciate you all. I'm gonna end the stream here though. And on Twitch, we're gonna raid out. So hopefully you two people have a good night or good day. And see y'all later.